Hey there, it's Jason Gorman from Codemanship with another video diary entry. Before we begin, if you're enjoying these videos, please like and subscribe and ring the bell for notifications. Okay, this video diary is entitled The 7 Self-Fulfilling Prophecies of Test-Driven Development. As someone who trains and coaches teams in TDD, I get asked a lot, as you can imagine, what are the benefits of doing TDD? What would we expect to get out of this? And the way I see it, the way I've observed it over the last 20 plus years is there are a number of benefits that are kind of self-fulfilling prophecies because of the way that we do TDD. If you're doing it the way that I teach it and encourage teams to do it, then there are certain benefits you're almost guaranteed to get. Starting with the most obvious benefit of all, if we obey the golden rule of test-driven development, which is that we only write solution code when we have a failing test that requires it. We only write code to pass tests. It stands to reason that we're going to end up with code that is fully tested. So teams that do test-driven development tend to find that their test coverage is very high, certainly 90% plus usually. So the vast majority of our code is covered by automated tests. And the second benefit that we get as a result of that high coverage, if we're doing it well, is that we tend to find that code that is test-driven has low bug counts. It's much more reliable. So we get higher test coverage, and that gives us much more reliable code. And that's a good start. But is that by itself worth the effort of learning and practicing TDD? There are more benefits we need to think about. For a start, and this has been measured, I've measured this with my clients, and other people like Keith Braithwaite have done studies into this and got similar results. We find that code that is written test first tends to be much simpler. Basically, classes tend to be smaller, or functions tend to be shorter, etc., etc. And there may be multiple reasons that we end up with code that is simpler. For sure, if we're only writing code to pass tests, we're not going to write any code that we didn't need to pass a test. So if our tests are meaningful, they're about end-user outcomes, then we're only writing code to deliver those end-user outcomes, only the code we need. And in a way, and this is a way that Steve Freeman, the co-author of Growing Object-Oriented Software Guided by Tests, sort of pointed out to me, in his belief, and I'm inclined to agree, forcing people to write a test first for anything they want the code to do introduces a sort of complexity overhead, a complexity tax, if you like. Yes, we can make it complicated, but we're going to have to write a lot more tests, and it tends to steer us towards solutions that are simpler. So we believe for that reason, and also because of that explicit step in the TDD cycle of refactoring, we tend to find that code that is test-driven ends up being much simpler, which makes it much easier to understand and much easier to maintain and far less likely to go wrong. So that probably contributes to the reliability of test-driven code. The next thing we tend to find is that code that is test-driven using unit tests tends to have a better separation of concerns. In particular, we tend to find that external dependencies are abstracted away for the purposes of stubbing and mocking them. So we don't write tests that necessarily are calling web services as part of our logic or speaking to databases or reading from files. We abstract that away. We might cover it with integration tests, but it ends up being a small number of tests for a small part of the code that has direct external dependencies. The bulk of our code has much better separation of concerns. So we tend to find that code that is test-driven is more modular, and that gives us other advantages. It means that most of our tests can run fast because they don't have these external dependencies. The majority of our tests will be fast-running, let's call them unit tests, for the want of a better word, fast-running tests that do not involve external dependencies. So we end up with a testing pyramid, that is the distribution of our tests compared to their execution time is a pyramid shape with the base of the pyramid, the bulk of the tests being fast running, and our test suites overall being much faster running than we tend to find happens when people write the tests afterwards, and then they start thinking about separation of concerns. Fast running test suites give us another advantage. If our tests run fast, that means we can be confident pretty much all the way through development, continuously pretty much. We can be confident that our code works because it's being tested and retested and retested and retested many times an hour. So we never step far away from code that is passing all of its tests, which means that code is potentially shippable sooner. So when we do test-driven development, we tend to find those teams, those products can be shipped more often, and features and change requests and bug fixes, if they're needed, can be shipped sooner. We call this continuous delivery. Our code is continuously shippable. And a key element of that is being confident that it actually works. And we tend to find, in fact, I'm not aware of any teams that are genuinely doing continuous delivery. They're shipping and shipping and shipping and shipping whenever the business wants, without, expensive sort of costly and long-lasting acceptance testing phases, or stabilization phases, and those kinds of phrases they use for fixing all the bugs before we can put it into production. With TDD, we tend to find that is not necessary, and therefore we can go into production sooner, and that has some big business benefits. If I was trying to sell TDD to a business, I would sell it on this and on the final of our self-fulfilling prophecies. It's a big deal. It's a real company killer when your tests run slow and you're always weeks or even months away from being able to ship software. I've seen that bring down some big, well-established businesses because it means you can't adapt. And finally, we also tend to find that pace of delivery, that pace of continuous delivery, is much more sustainable. We can keep delivering and keep delivering and keep delivering. Like the Energizer Bunny, we can just keep shipping and shipping and shipping, month after month, year after year, because one of the biggest factors in how much it costs to change software is how long it takes to test it or to retest it. The longer it takes, the more bugs are going to slip through because we're testing less often, and therefore we're back to that nasty picture of big bang releases every 6 months or year with lots and lots of sort of after the fact testing and bug fixing, which is very painful for a lot of people. So I've certainly found over my career, and I've worked with a lot of teams doing TDD myself, and also spent time with a lot of teams who are doing test-driven development or transitioning to doing TDD, and in almost all cases we found that they eventually, after a while, after they got over the learning curve and fixed some of the legacy that they had, some of the technical debt, reached a point where they were able to ship and ship and ship and keep shipping as often as the business needed them to and as soon as the business needed them to. So there you go, the 7 self-fulfilling prophecies of test-driven development. High test coverage, low bug counts, greater simplicity, we've measured that, better separation of concerns because of stubbing and mocking, faster test suites, a real test pyramid basically, which means we can have shorter delivery lead times, continuous delivery basically, and more sustainable delivery. We can sustain the pace of delivery on a product that basically the longevity of our products and systems is much longer. It's sustained. So there you go. That's why I do TDD, and that's why I encourage teams to practice TDD. That's not to say that there isn't a bit of a learning curve to get over first, typically 4 to 6 months of regular practice to get the hang of this so you can start to reap the benefits. And the benefits won't come immediately, particularly if you're working on legacy software. It'll take you a while to turn that software around, turn it into something that can be test-driven. But believe me, it is worth it if you can do it. So there you go. There's my short video diary entry for today. I do apologize that there was a PowerPoint slide involved, and we'll try and do some coding in the next one. You take care.